Hi, everybody. Today, you see the title on the top there, putting it all together. Really, what we're going to do is we're going to deal with all of our operations in simplifying expressions. So, really, what we're coming to is an order of operations day. Can we take what we've been working on for the past few days and can we throw it all together? So, what you see on the screen in front of you, those are going to be our 4 examples that we're going to go through today. And I think if we were able to walk through these 4 and then jump in and get some decent practice at some stuff, I think you're going to have everything you need moving forward. So, for us to begin on some stuff, I hope that we all have our Bedmas completely locked down and we are good. I've talked about that a number of times up to this point. We've reviewed it in passing. I hope that we've got it locked down for today. I'm hoping that some of those details, like our division and multiplication, can be done in either order. Our addition and subtraction can be done in either order. That there really is no operation called brackets. And so really what we're looking at as we jump into today is, can we take our Bedmas or order of operations and can we take some relatively straightforward looking expressions like A and B and then work our way into some uglier expressions like C or D and be able to go through that simplifying process. Okay, this is so much of a review day for us that I want you to get out ahead of me on every single problem. But what we're basically going to do is we're going to kind of break this up into 2 parts. So what I'd like you to do is to work your way through both A and B. Get a solution, get down to something fully simplified. Then we'll come back, we'll take a peek and see how A and B went, and then we're going to jump in and do the same thing on C or D. So what I want you to do is to go through, get full solutions for A and B. Okay, pause it now. Okay, so we're back. So again, don't just follow this through without working through it on your own. We're trying to build some instinct as we go. So I'm assuming you have a solution for both A and B, and now it's just talking about how we get down to that solution. A little confirmation to see if we match up with the final expression, but also let's make sure that we're picking up any theory as we go. Okay, my eyes have to go in that first expression, if we're looking at A, to the minus, the divide, and the multiply. And as I take a peek at those 3 operations that I've circled, now this is when Bedmas kicks in. I notice that I have subtraction, divide, multiply. I cannot touch that subtraction at the very beginning. I have to deal with my divide by, my multiply, and when I have my expression written in this single line, then I have to do what operation comes first, left to right, within my multiply and my divide. So I'm going to leave that 6 and the minus that you see highlighted in purple out in front. And the first thing I need to calculate is my negative 30 divided by negative 5. So first off, I get a negative divided by a negative. That gives me a positive. 30 divided by 5 gives me 6. Now I still have left on my times by my negative 7. Make sure that we have brackets around that negative 7 to avoid the double sign between the multiply and the negative. Okay, I think that cleans up the problem pretty quick, and we're probably pretty good to finish it off. If we showed enough discipline in that first line to recognize that we can't deal with the subtraction, then I'm leaving that there and you could go through and calculate. Now, this is one that we talked about on our integer review day, and this is one that I want to readdress again. If you wrote down what I have down, the 6 and then the minus, then what we're calculating is a positive 6 times a negative 7. Okay, that leads us to a negative 42. We now recognize we have a double sign, so we now need to change that into a 6 plus 42 to get to our single sign, and we can calculate. Okay, that's not too painful. That should get us there. However, I would like us to maybe take a look at something different. Similar to what I said to you back on that integer review day, here's where we can jump a little bit. You take a peek, and rather than just blindly writing down 6 minus, I'm going to write down my 6. I know I can't touch that subtraction sign yet, so I'm going to write down my 6. Well, the next part becomes, if I can be a little more inclusive with that subtraction, and I can also view it as a negative, then what I really have is a negative 6 times a negative 7. And now my negative times a negative gives me my positive, and my 6 times my 7 gives me 42, and I get to avoid my double sign. So I can go straight to 48, and we are good. So much so that I would bet that I would have a large number of you that could go from this line straight to your final answer if we include that negative on that 6. Okay, hopefully we matched up in our solution. I'm going to erase all the little writing I have in my expression, but hopefully we matched up with that 48. Okay. If I get rid of everything that I just put down in that original expression, and you see that expression that you have, I want to put maybe a new idea in your head. It's some terminology. We're going to address it when we get into our algebra units. But I think it can really, really help you out with just some common algebraic expressions. In this case, some calculations. Okay. For us to separate terms, for terms to be separated, they have to be separated by add and subtract signs. Addition and subtraction act like walls. You can't cross them until you've simplified each term. So if I look back in this original expression, this may be a little weird to you, but it's like I have two terms because there is my subtraction. So when I look at that and I recognize that's my only subtraction operation in the expression, what that blue circled subtraction sign does is it separates this into two terms. I have the 6, which is one term, and then I have this big ugly term in the end. So I can't touch that blue circled subtraction operation until I've simplified both my terms. So that's what helps you out a little bit to go, oh, okay. So that means I have to leave my 6 out in front. And now I do all the work to simplify that next term. Once I have them simplified, well, in this case, my negative was turned to a positive in eliminating double signs or through operation. Now I can finally use that add or subtract symbol. So you're going to hear me going forward saying so often, well, how many terms do you have? Well, let's recognize the number of terms. Which term is the number of terms we have can be super useful. Okay, let's see how some of that stuff comes to play in question B. So we take a look at B, and again, we're just matching up. We see all of our operations. We have a multiply, we have a subtract, we have a ton of brackets, and then inside, the most inside brackets, we also have a plus and a multiply. So we've got a lot of operations on this line. Okay, what does Bedmas tell us to do here? Well, Bedmas tells us to do the operation inside the brackets first. Well, that doesn't really narrow it down. That was inside the brackets. That was inside the brackets. That was inside the brackets. Well, if what I do first is what's inside the brackets, then within those big squared brackets, I have another set of brackets that I have to do what's inside those brackets first. So I always have to do what's inside my most inner bracket. So I'm just going to try to get rid of these big purple brackets I drew on and then these smaller round brackets. So what I need to work with is what's inside my most inner brackets. Well, that at least narrows it down to 2 operations. So now I have to work between my plus and my multiplication, and Bedmas tells me I have to multiply first. So I've got a little bit of copying to do within this problem. Okay, so I can't touch, sorry, I want to do this in red. I can't touch the 2 times out in front. I've got my big square bracket. I can't touch that 3 minus yet. And inside my brackets, I can't touch the 4 plus yet. So we're going to show a little discipline. We're not going to write the plus. We're going to let the signs of things work out. So we should be pretty good that then the first thing I have to do is that 6 times 2. So I calculate my 6 times 2, and there, is my 12. Now, I'm not saying you have to write that line down. That we are doing a series of operations, and depending on where we're at with some things, you may be able to do more operations in your head than that. That is, I would expect I would have a ton of people that could leave all that other stuff and instead say, okay, 6 times 2 is 12, add on my 4, there's my 16. And we jump straight to that line. Okay, hopefully we got down to that point. And we're now good that we've dealt with all the operations inside our inside brackets. Okay, now what do we have to do? Well, we still have to deal with all of our operations inside the brackets. So I now have to deal with my 3 minus 16. There is my negative 13. We all have brackets around the negative 13 for that whole double sign issue. We got to watch out for it. And now we can just finish off with a quick calculation. We come in on negative 26 and we should be good. So as you guys take a peek at it, I'm hoping that we can be slow and methodical if we need to be. But no, you can jump some steps from time to time. Okay, I'm going to call those your 2 pretty straightforward expressions. Hopefully we've matched up, or hopefully we've looked at it and now we remember some things, or we've maybe had our eyes open to some new stuff. Now what I want to do is I want to jump into those uglier expressions. Okay, so what you see now on your screen is question C and question D. So there's those 2 expressions. We have the same instruction. I wanted to put it on the screen. We're still just asked to simplify. But those are going to get considerably uglier. Okay, now what I want us to do is I want us to give both C and D a shot. I think there may be a likelihood that we hit a bit of a wall at some point. All I'm going to say is if you hit a bit of a wall, fight through it. You know, if you just quit there, then you're going to be wrong. So there's no penalty for being wrong. You go through, you get down to a final simplified form, and we will go through and we will confirm some stuff and talk. Now, if you hit a bit of a wall on C and you want to jump over to D, that's no problem. But when you're done D, you better jump back to C and get a full solution for that one. Okay? Next time we come back together live, I want you to have a solution to both C and D. Okay, we're back. So we've got to a point now where you have a solution to C and D. We're going to slowly walk our way through C. The first thing, again, that I would want us to do, and I'm just going to quickly go through and seriously highlight everything. What we end up having is an addition on the top and a subtraction on the bottom. Now, within each of those, that divides our top and our bottom into multiple terms. Remember, add and subtract separates terms. So I now also have a multiply and a divide, and then this big, huge divide operation. So that expression in C has a lot of different operations we need to do. Your job is just to be slow and methodical. So what I'm going to do is I'm going to get rid of all of that stuff that I just put on and get us to get our focus in. Okay, this big fraction line that you see that I just circled in the middle, that is our dominant division operation. So that's what's really going to break our problem apart into like two mini expressions. The problem that some people have with their solution is they might do this. Okay, I'm going to take that top solution and I'm going to go through and I'm going to start calculating. And I'm going to work it way down. And hey, that top number works out to be 16. I don't know if it's 16. I just made up that number. Then what they do is then they go, well, I'm going to take that bottom expression and I'm going to go through and I'm going to calculate, hey, and that works out to be 8. Now what I'm going to do is I'm going to say, hey, 16 divided, don't do that. Because what you're doing then is creating new expressions. Don't do that. It's not going to help you with where we go in the future. So my suggestion to you is going to be, just keep it all as one expression. But since that big purple division operation, that fraction line, divides top and bottom, then start to pick away and do operations on top and operations on the bottom, as long as we make sure we don't cross it until we've simplified the top to one term and simplified the bottom to one term. Okay, if that's the case, then let's zero in on the top. I'm going to highlight in green. That is my big divider. That plus sign that I see on top is what breaks that top into one term and another term. And what you'll notice within those terms is I have an exponent, I have a multiply. In the other term, I have multiply. Look at my red operations. I can do those all at one go, or I can do those at one time. Look at my blue operation. I can calculate that multiply. As long as I don't cross the green, as long as I don't do that add, then I can simplify each individual term. So maybe my next line looks like this. Okay, I know if I look at my first term, I have an exponent and I have multiply. I know I need to do an exponent first. So I can't touch the times, but I can calculate negative 2 cubed. Well, negative 2 cubed is negative 2 3 times separated by multiply. So negative 2 times negative 2 times negative. So a negative times a negative times a negative will give me a negative. And 2 times 2 times 2 gives me 8. Okay, there's my negative 2 cubed calculated. Well, now I have the plus in between. There's my addition. Well, now I can calculate my 5 times negative 4. And maybe I come right in on negative 20. Now, I write that down that way so we can see those multiple operations. However, if I don't blindly write the plus down, then I can come in instead on a positive 5 times a negative 4, and therefore that is a negative 20. I can get my top line to come in right like that. Hopefully not too bad. There's my big fraction line. Okay, I can do the same thing on the bottom. That minus sign is going to separate my terms. My first term has a multiply. My second term has a divide. So do the multiply and do the divide within each term, but don't cross the subtract. So my first term becomes 5 times negative 2. That's a negative 10. My second term efficiently is a negative 32 divided by 8. So there is a negative 4. Okay, we can start putting some stuff together. Now let's look on top of that big fraction line. Notice we have multiply and we have subtract. I'll do my multiply first. So 4 times negative 8 is a negative 32. I can't do that minus 20 yet, or maybe I can do it all in my head. On the bottom, at least I can take a negative 10 and subtract 4 more. So that's a negative 14. On the top, I now have a negative 52 over negative 14. And now I can look to reduce, to simplify. Okay, so what do I have? Well, I have a negative divided by a negative, so I know my answer is going to be a positive, but I'm not going to write the positive down. We've already talked about that. Maybe you take a look at your 52 and your 14 and you say, hey, well, both the top and the bottom are even numbers. I can divide by 2. And when I divide by 2, I get 26 over 7, and that is a fraction that does not reduce further. I am finished. Nice. So I'm hoping we can take a look at that question C, and we're relatively comfortable to go through and slowly, methodically deal with our operations. But there's also a way where we don't turn an expression that could be done in 4 lines into one that's done in like 20. Okay, I may have addressed something that you kind of were unfamiliar with, or maybe it's something that you like. And maybe we may have hit a snag in D that we think we could get through now. So I have no problem if you want to pause the video and give D another shot. Otherwise, I think we should be pretty fast to move through D. Okay, so you're coming along because you have a solution to D. Otherwise, you're going to pause it and try it on your own. Okay, question D for us is a good old fraction question. But just keep in mind, fractions are division operations, so it's just an order of operations. You see a number of mixed numbers in there, so I think a good first step, let's change them all to improper fractions. We should be good to slowly go through. Oops, I don't know why I wrote down 3. And my suggestion to you would be change them all into an improper fraction. Okay, now that we have that, I think our operations jump out. We see the division on the inside, so we know we can't touch this 7 halves. We now have our 5 fourths. We're going to divide it by 11 fourths. Well, to divide fractions, we know that we flip and multiply that. Can't touch the minus 3/8. Okay, here's where I'm going to say you really have the blinders on. I would hope that this is your next line. But I'm going to bet and say some of you guys don't have that. So make a note of why. I would hope that when we take a look at this multiplication operation we have to do, that you see that we can cross-reduce with those 4s. So rather than having a 20 over 44 middle fraction, I can go straight to a reduced fraction. Okay, why is that going to help me maybe? Because that might allow me to work with smaller numbers, maybe a smaller denominator. Always look to reduce whenever you can. Okay, we got down to my last red line. Now I have add and subtract, so I'm going to work left to right. Well, I need a common denominator, and I'm hoping that we see that the best common denominator I can choose is going to be 88ths. I can turn a 2 into an 88 by multiplying by 44. That means I have to multiply my top by 44. Yikes, that's going to be big. Now, for you to go through and deal with that, I get where you might have bailed out and used a calculator. I'm hoping that at the very least we hop off and maybe address 44 times 7 and do with some long multiplication. So we've got our 7 times 4, I don't know, 8, carry a 2, 7 times 4 is 80, 28, add on another 2 is 30. Maybe we go the opposite way and say, hey, 7 times 40 is 280, plus another 28, there's a 308. I don't know how you want to deal with that. Now we work to that, we have our 308 as I switch colors. There we go. Now we take a look in the middle. What would you multiply 11 by to get you to 88? So multiply the top by the same. That makes our numbers a little more manageable. And now you look in the last. What would you multiply it 8 by to get you to 88? Multiply the top by the same thing. And what's really nice when we go and we put that stuff together, what is a positive 40 minus 33? Well, that's 7. So let's make sure that we add 7 to 308. And there is our 315 divided by 88. Okay, nice. Now, biggest thing, we have to make sure we simplify. So is that fraction fully reduced? Remember what made up your 88. That was 2 times 11 times 8. Well, an 8 is a 2 times 2 times 2. So the only numbers that really make up an 88 are 2s and 11s. So our only peak is, does a 2 divide into 315 evenly? Nope, because it's not even. And then we're checking on, well, does 11 go into 315 evenly? So that's really our only check. And we notice it doesn't. And so we know that 315 over 88 is fully reduced. There we go. Hopefully not too bad. Okay, that takes us through a full review of how to simplify expressions following order of operations. I think these 4 problems kind of give us some experience with a number of different issues. I would say draw back on these as you jump into your practice. I think if we knock out a decent amount of practice on this topic, we're going to be pretty comfortable and pretty smooth with our order of operations. Okay, jump in and get some practice. Good luck.